We're learning how to apply the rules of indefinite integrals for sine and cosine functions. We're going to stick to fairly straightforward functions in this video. While the following is not a proof, it demonstrates, perhaps to some degree anyway, where these rules for integration do come from, and they're linked to finding the derivative, which we know how to do. So we consider a trig function. So let's consider sine 5x, and if we take the integral of that, how do we do it? What's the result? Well, we know that the derivative with regards to x of cos 5x is negative 5 sine 5x from our previous work. Now, so the answer to this here, this integral, is not cos 5x. So it's not that straightforward. However, it does have the integrand, which is the thing, the integrand is the thing that's being integrated. It does have the integrand in the answer there, but it's too big by a fact, or magnitude's too big. It's out by a factor of negative 5. So let's try the derivative of the reciprocal of negative 5 whacked on the front. So let's take the derivative of negative 1/5. I'm going to use some brackets there to keep it orderly. Negative 1, let's tidy that up. Negative 1/5 cos 5x this time. Cos 5x on the derivative of that. So if we do that, we'd end up getting sine 5x. So going back the other way, the integral of sine 5x will be negative 1/5 cos 5x plus c, plus arbitrary constant. It can be any constant at the end of that. So we can use some rules around that, because we could go ahead and use some other variations, and we could get plenty of results which are consistent with these rules. Here they are. Please take note. We have integral of sine ax plus b, where a and b are constants. So in fact, a, b, and c are constants, so they're real numbers, in other words. So we have integral of sine ax plus b with regard to x is negative 1 over a cos ax plus b plus the usual arbitrary constant on the end. And integral of cos ax plus b is 1 over sine ax plus b plus the constant. So please take note of those. We'll do one example. Okay, so let's try the integral of cos 3 over 2x minus 2 dx. And you probably won't need to do this once you've practiced a few, but it's good to see what a, b, and c are explicitly, so we can match it to the formula there. So maybe for the first couple you might need to do this, you might not. So c is just going to be plus c, of course, so I'll leave that. And we're looking at the second rule, and simply the reciprocal of a, well, a is 3 on 2, so the reciprocal is 2/3. And we've got cos reverting to sine, and we've got a as usual. A hasn't changed inside the brackets, just matching the pattern that we've established from our work. And voila, we have our answer. So perhaps if it's a fraction, and maybe, hopefully not, but maybe you might still not be as confident as you like with fractions. If you do have fractions as the constant, perhaps isolate them in that way. When you go 1 over a, it's an easier matter. Okay, so if a is 3 over 2, 1 over a is 2 over 3, because a itself is a over 1, isn't it? So take the reciprocal of both.